Ladies and gentlemen, thank you so much for joining us today. On behalf of AUVSI, I am very pleased to welcome you to today's webinar, How to Scale Drone Workflows for Architecture, Engineering, and Construction Operations. My name is Shannon Whitney, and I am the Education Manager here at AUVSI and host of today's webinar. Before we get started, we have a few housekeeping items to note. All of the participant lines will be muted during today's broadcast. A recording of the program will be emailed to all attendees and posted to auvsi.org within the next few days. If you're listening to the broadcast and need assistance, please send a note to AUVSI support using the chat box on the right side of your screen. If you don't see the chat box open, please click that chat bubble icon that is in the bottom center of the screen. This will open the chat box panel on the right side. After the presentation today, we'll open up the session for Q&A. Attendees, you are encouraged and welcome to submit your questions at any time throughout the webinar presentation using the Q&A box on the right side of your screen. But the questions will only be answered at the end of the presentation. So another important note is that this Q&A box is different from the chat, so please make sure that all of your content questions for our speakers are submitted using the Q&A box. So let's get started. We would first like to recognize and thank our sponsor for today's webinar, Esri, for their generous support. And I'm now happy to introduce our three speakers for today. Øystein Lovell, Survey Manager at Skanska Norway, Anders Alvesen, Geospatial Specialist at Skanska Norway, and Jeremiah Johnson, Business Development Imagery at Esri. Thank you all for being here with us today, and Jeremiah, I will now turn the presentation over to you.
Thank you so much, Shannon. Good morning, good afternoon, and good evening to everybody. Thank you for joining in. I'm really excited to share this presentation with you guys today. We've been working with Skanska Norway for quite a while, and this is a pretty interesting project that I want to highlight. So I'm really glad to be presenting this to you. Just a little bit of introduction. So I'm with Esri. I'm with the Global Business Development Imagery and Remote Sensing team. My background is aerial mapping. Started with manned aerial mapping with airplanes and helicopters. Then I moved into mapping with drones, so for various industries, ranging from construction and architecture to mining and natural resources. I'll let Øystein and Anders introduce themselves as well.
Yeah, hi everyone. My name is Øystein Lovell. I've been with Skanska Norway for most of my professional life since 2004. I started as a surveyor, worked a while with BIM and quantity calculation, and now I'm back in surveying as survey manager at the project Nordveien, which is located just some 10-15 kilometers from my home. And this project you will hear a little bit more about in a while.
Yeah, hello everyone. I'm Anders Alvesen. I'm a GIS specialist in Skanska Norway, and as Øystein do, I've been working a lot with quantity calculation and GIS.
Oh, great. Thanks, guys. We'll be coming back to them in a little bit. Here's the agenda for today. I'm going to introduce the Esri drone collections to you. I also want to introduce SiteScan for ArcGIS, which is kind of the main software that we're going to be highlighting today. And then I'm going to hand it off to Øystein and Anders to talk about how they've been using drones and other technology on their project in Norway. So first of all, I want to introduce the drone collection. So one of the reasons why Esri has really been pushing hard in drones over the last 3 or 4 years is that a lot of the customers that we have around the world are coming to us saying, hey, we're starting to use drones in our workflow. This is something that we're interested in. This is something that we see value in. And these are kind of the 6 industries that we have started to see come up or bubble up to the surface. I want to highlight just a few of them. In transportation is a project that we're going to be talking about today. Whether you're building new infrastructure or inspecting existing infrastructure, I think that the use cases for drones are nearly limitless. And in architecture, engineering, and construction, or AEC, we're seeing drones being used in a wide range of capabilities. This is an industry that, for the most part, had been, pencil and paper for many, many years, even after we started designing buildings with CAD and 3D. Everything would get printed off onto pieces of paper for the job site. But we're starting to see a lot of digital transformation on these construction sites. And drones play a key part or a key role in that transformation. We're seeing in mining, companies being able to better monitor their open pit mines with drones, be able to get quantities and improve safety of the mine itself. Government, whether it be national government, state and local, all the way down to cities and counties, they're using drones in different ways, whether it be monitoring existing infrastructure, assessing environmental capabilities of of waterways or of green spaces. Utilities, we have upstream, midstream, and downstream in oil and gas, where you're inspecting factories or refining stations, all the way down to right-of-ways and pipelines. And so as these customers come to us and they're starting to use these drones, and one of the things that they want is a seamless end-to-end workflow. So we want to fly this drone, we want to capture this data, and then what do we do with the data after it's been captured? So we created these 4 drone collections. The 2 to the left are offline, and they use a product called Drone2Map for the processing. And this is Drone2Map is a desktop application that ingests drone imagery and then outputs point clouds, 3D meshes, and orthomosaics. This is suitable for obviously offline use, as well as smaller operations where you're flying maybe 1 or 2 drones. But once you have an operation that is requiring more drones, more pilots, and you're processing more data, you want to move that into the cloud. And so we have 2 new online drone mapping collections. So we have the online drone mapping collection and the enterprise drone mapping and analysis collection. And we've moved all of the processing into the cloud here. And they use SiteScan for ArcGIS for the processing engine. So this is the drone collections that we're going to be talking about today. SiteScan for ArcGIS is a cloud processing and analysis software solution. So it handles the various phases of drone acquisition. I'm going to talk about that next. SiteScan for ArcGIS has a number of benefits, reducing capture time by pre-planning flights and being able to submit flights using the cloud connection to pilots in different areas is highly beneficial. Enhancing data accuracy, so being able to input ground control points and tie data down to survey points in order to increase the accuracy. Reducing operational costs, so being able to cross-reference past data with today's data, so you can QA, QC. We talked about improving in safety and productivity on mines, but obviously this is something that's important for almost every industry, is being able to monitor the goings-on construction sites, on mining sites, and on infrastructure projects. Being able to automatically track these drone fleets, because everything's tied to the cloud. Everything is captured and recorded online. So you can see exactly what drone has flown where, for how long, who flew it, what battery they used, and all of that is tracked automatically. Having everything stored in the cloud increases collaboration, so you no longer have data products that are sitting on your desktop at your desk. Everything's already in the cloud. So as a flight is happening in Norway, managers can see that data and analyze it anywhere in the world. So with SiteScan for ArcGIS, like I said, it's a solution that encompasses a few pieces. The first piece is the SiteScan flight planning app. I'm going to talk about it in a little bit, but this is an iPad app that you use to connect to your drone, plan the flights, and execute them. Once the flight has been executed, the photos are uploaded to the cloud, where the images are processed using a couple of different processing engines. that produce the 2D and 3D data products. That data is immediately available in the SiteScan Manager app, which is a web application where you can do basic measurements, analysis, time series changes, and much more. And then we have the connector piece that connects the SiteScan for ArcGIS with your ArcGIS Online and ArcGIS Enterprise portal as well, because you can't necessarily do everything inside of the SiteScan web app, and there might be some workflows that you want to use in ArcGIS Pro or Image Server, and you have a direct link from SiteScan to ArcGIS using that connector. So going deeper into the product, so this is the SiteScan Flight Planning app. It's an iPad application that's built on the ArcGIS Runtime SDK. What's really interesting is that it's drone agnostic. So there's a piece that can talk to a variety of different drone autopilots, and we support quite a few drones. But as we start to see the drone hardware industry changing, we are able to continue to update this app to support more drones without affecting the workflow. So any of these flight plans that you see here that you can create, you can actually, you don't have to worry about what drone you're flying or what drone the pilot will end up flying for that flight plan. It's a complete field data management platform. So in addition to planning flights and executing the flights, it also keeps track of the photos collected from a flight. So you can fly 5 flights, 10 flights, import all of the images into the iPad, and the iPad understands which photos belong to which flight. Those of you who are used to mapping with drone software know that inputting your SD card into a computer and looking at a folder of 2,000 images, sometimes it's difficult to know which images belong to which flight. This is something that the iPad app is good at. Fleet management, like I mentioned before, is critical, especially as you start to scale up your drone workflows. So being able to track who flew what drone is really important. And kind of what goes along with that is organization-mandated custom pre-flight checklists. So the software will go through a pre-flight checklist that just ensures that the drone hardware is good to go and all the sensors are functioning properly. But we have the ability for an organization administrator to preload or custom create a pre-flight checklist so that pilots, before they're flying, they can input items like the weather or their pilot certificate number, what authorizations or airspace authorizations they have to fly, and all of that gets saved up into the cloud for review. The next component is SiteScan Manager. Like I said before, this is a web application, so you access it through the browser, and it's a complete analysis and collaboration tool. So everything that is collected in the field gets uploaded, processed, and is available within the SiteScan Manager application. You can also import overlays like CAD overlays or PDF overlays so that you can see how the drone data compares to the drawings that you might have. You can also generate inspection reports. So some of our users are using SiteScan to automatically fly around structures or towers, and being able to create those 3D point clouds and then do inspections based off those, and then create a PDF report of those inspections is critical for those customers. You can also perform volumetric and cut fill analysis with one click. So being able to create the volume of a stockpile, for instance, is really basic. But when you're able to collect and measure the volume of that stockpile based on maybe a land XML or a 3D design surface, it makes that very, very powerful. Next, I'm going to kind of show you a demo video. The SiteScan flight planning application is very powerful. It's kind of difficult to show on a slide. So I created this workflow video to kind of show how it goes. And we can press play here, and I'll just talk through the video. Great. So the first thing you'll notice is that it pulls up the latest base map of the last flight that you created. So you can always create your next flight based on your previous flight data. Here I'm going into my ArcGIS Online account and pulling in additional data from my ArcGIS Online account. So there's a direct link between the SiteScan Flight Planning app and your ArcGIS Online account. So anything that you have stored up there, whether it be 2D or 3D, could be viewed on the Flight Planning app for better flight planning. So here I'm just changing the hatch angle to create a more efficient flight. And I'm going to view this flight in 3D just to see what this flight will look like. You see the little pyramids there. Those are showing the individual photo capture points. So you can see not only where the photos are going to be taken, but at what angle the photos are going to be taken. So this is that basic pre-flight checklist. So it checks all the sensors and GPS and the camera and SD card. And you take off and you see the live video feed on the upper right. And you will see the drone path that it's going to take, that white dashed line. And then the blue lines are the drone path that it's going to fly. As with everything, I can view this in 2D or 3D. So here I can see the flight as it's being captured in 3D as well. If I had a 3D scene from my ArcGIS Online account showing maybe point clouds or meshes, or if I brought in 3D buildings, I could view that in this window as well, which makes the situational awareness just pretty incredible for the pilot, being able to see exactly where the drone is next to any obstacles that I had pulled in as well. So you see as it completes its flight, you'll see the live feed up on the upper right kind of pause every time it's taking a photo. You have telemetry on the top there showing distance from home, height above ground, connection status of the drone as well. This is a pretty short flight, so it'll complete in one battery, but if I had a larger flight that required more flight time, it would fly until the drone battery reached a level at which it needs to return home. The drone will automatically return home, at which point I can swap out the battery for a new one, and then it'll go back and fly back to its last point and continue the mission. So I can really fly as large of a mission as I want using this method. So here we're coming up to the last waypoint, and it's going to come back home. Again, I can view this in 3D. So you can see the return home dashed line is showing not only the path it's traveling, but also the descent there. And as it descends, you can see exactly where it's going to descend to. Perfect. So after the drone lands, you have a couple of different ways to get the photos. You can wirelessly transfer them from the drone to the iPad, which you're going to see here. Or I can take the SD card out of the drone and put it into a SD card reader for my iPad and pull it that way. Sometimes if you have a lot of photos, it's easier to just pull them straight from the SD card to the iPad than to wirelessly transfer them from the drone. This is what it looks like whenever you're wirelessly transferring them. I can open up and QC each of these raw images. I can zoom in, I can verify quality, I can verify that my camera settings were correct, and I can even verify the geolocation of the images right there on the iPad. Once the images look good, if you have a cell signal on your iPad, then you can upload them straight away, else you can wait till you get Wi-Fi and then upload them from there. Once they're uploaded, we immediately start a processing engine for those groups of photos. So the user didn't have to worry about starting or stopping the processing. Great. Now, a little bit about the project. So I'm going to hand it off to Leistine and Anders, but quickly, I wanted to talk a little bit about the Skanska drone program. So the Skanska drone program is not just in Norway. Skanska, if you don't already know, they're a massive global engineering firm. They're actually Swedish, but they have offices all around the world. For the most part, if you are in a city and you see something being constructed, most of the time you're going to see the Skanska logo there on the fence. So pretty significant company. They're starting to roll out their drone program in chunks, but right now they have 293 total users. 26 of those are pilots. Around the world this past year, they've completed 745 different drone flights on 86 active projects and 40 projects that are now completed. So I thought that it would be great to pull Skanska in order to talk to us about kind of how they're using the drones and drone data, and specifically about the Noorderwegen project, just because it's such an interesting project and a great use case for drones. So I'm going to hand it off to Øystein to talk about the project.
Yeah, so this on the slide here is the project Noorderwegen. It's located on the beautiful west coast of Norway. The project's purpose, if you can say that, is to connect these 5 islands to the mainland. Just to connect the first island at the bottom there, we need to have 2.5 kilometers of ocean filling to make new terrain land in the sea. And also this ocean fillings will be connected by 3 bridges at 800, 200 and 100 meters. And from these we are building a road and tunnel between the remaining islands, 3 of which are underwater tunnels, at the deepest going to 130 meters below sea level. And the total length of the project is about 35 kilometers from start to finish. We started this project in March of 2019, and we will hopefully be finished in about 2 years' time. As mentioned, the project is spread out on 5 islands, which today are connected with 2 different ferry routes, or they're not connected at all. Our main site office is at Shelton, at the bottom right corner. And to travel from office to visit the sites in person, it's very time consuming, and even though I haven't tried it yet, it would take some 10, 12 hours to visit them all. And with that ocean filling, we are kind of building 6 artificial small islands in the sea, which are only accessible by boat. And to be in some kind of control over this vast and complex project, we needed to find a way to get the overview and data of what we are building. Basically, we needed to get reality back into the main office. So then we started to fly and to generate orthophotos at a regular basis. We started with the one drone, Phantom 4 RTK, and started the drone mapping from every site about once a month, but soon realized that we needed one more drone, so now we have 2. We set up a geo server where we upload the orthophotos and give access to this for the whole project organization. That's not the only benefit the drone mapping has provided us. After starting with the data collection to the drones, we now collect data on areas which we would never measure before, both due to safety and accessibility. And also data through SiteScan gives us much more relevant and irrelevant data than we traditionally would measure, and sometimes even the data we thought was irrelevant suddenly becomes relevant, and have the cloud storage at SiteScan that lets us investigate in data months and years back. The 3D data and the detailed output we get from the drone flights gives us the possibility to do basic quantity calculations, and the high-resolution orthophotos gives us a detailed level very useful for quality inspections of our work. The drone data, as from the photo on the right, gives us both excellent data on the quality of stonework, but also gives us the height data at area under sea level, for at least a meter or 2, depending on the visibility. And we also have more users of SiteScan within our project organization, where they measure and compare flights and timeline, and compare against design, and All this reduces the need for information and data from my server department. And we also want our client to access our drone data. And after they started using it, the demand for the traditional documentation, as in PDFs of cross-sections and sketches, has decreased a lot. And we want to be as transparent as possible towards our client. And in giving access to our data on SiteScan, we feel that there has been built much greater trust between us and our client, and that's built a very solid relationship. So this is basically the workflow we use here at the Skanska Norway. We started a year ago with basically no idea how to build this system, but now after around 100 and something flights, we think we have a quite efficient data flow system. And we basically fly the same areas every time, so the pre-flight planning in the office is now at the minimum. Our ground control points are mostly set and maintained, so there is not much pre-flight field work either. So we just travel to the area for mapping, do the safety measures, and start flying. Back with the computer, we upload photos to SiteScan, tag the DCP, and let SiteScan do its magic. And after some hours or so, the process is complete, and we upload auto photos to our Geo server, web viewer, and the point cloud to our calculation tools, Mesh and point cloud to the BIM 360, where we build a reality in design model in Navisworks, which you can see a picture from on the bottom left. And this model has some limitations for sharing and maybe user friendliness. And also with the unfortunate corona situation, which gives home offices for many of our and our clients' employers, the request and need for a more user-friendly and online tool for model and reality is something we want to develop more in our project. Luckily for us, we have a GIS specialist in our organization, and now Anders will tell us a bit more about progress in getting ArcGIS online up and running.
Yes, thank you, Øystein. Øystein talked about how we share the drone data today with the project team. And we're now looking at the possibilities to share these data with the ArcGIS online. So our main goal with this is to share data with the stakeholders in the project. And as you have seen earlier, we do that today. But team members are dependent to use desktop programs like Navisworks and some other programs that is not much usable for most team members. It's difficult for them to use. In SiteScan, it's possible to view meshes and point clouds in a web viewer in 3D, but there is limited possibilities to show the models together with 3D design data and other data sources. With Navisworks, we do share drone data together with 3D design data, but then again, team members need a desktop program and the files. So you're limited to desktop viewer with Navisworks. So what we want to do is to view all the data in a web viewer. That is 3D design data together with drone data, point clouds, and meshes. What we don't want to do in addition is having to thin the point clouds or make coarse meshes because of size limit or slow graphics on the files, or to consider the extents of the data sets before publishing. So how do we get there? We have started to test transfer of data from SiteScan to ArcGIS Online. And we started to test the transfer of BIM models to ArcGIS Online to combine those two. And the transfer of data from SiteScan to ArcGIS Online, that is quite easy. That is, with a few mouse clicks and a cup of coffee, point clouds, meshes, and orthophotos are transferred to ArcGIS Online and ready to be used in web maps or in 3D scenes. The transfer of the BIM models to ArcGIS Online are not that obvious easy. It's necessary to consider complexity or level of detail of the BIM data. ArcGIS Online can show quite complex BIM models, but it's not a BIM viewer. What works for us at the moment is to deconstruct the BIM model, identify and transfer the main parts of the BIM model. Details like the bolts on the steel bridge would be impressive to some of our users, but they wouldn't have the time to be impressed. Now, even though we don't get a full BIM model into ArcGIS Online, we will have enough geometry to answer a lot of questions from the project team. So what applications are we looking for? The obvious application is seeing 3D design data and 3D drone data together at one place and in a web viewer. There is value in not having to imagine the set as you do in the 2D views of the orthophotos. Other application is the ability to measure height, length, and area in the 3D scenes in ArcGIS. And as shown in the picture, it's also possible to make sections and do measurements in the sections. It's quite nice that the scene is available directly on mobile devices via the ArcGIS Earth app, and you don't have to do any extra configuration. You just need to download the app. And if you have an ArcGIS user, then you have the scenes. Hopefully with this, more team members can follow the excavation works and decide if it's proper or not. So there's lots of possibilities, and we're now at the stage of letting team members test the functionality. And yeah, that's it from me.
Great. Thank you, Anders. So, I hope that everybody got, at least a glimpse of how Skanska Norway is using SiteScan on this Nordvegen project. Through the process of working with them not only to create this presentation, but just kind of talking to them about this project, I've seen that this is a very important project not only for Skanska but for the Norwegian people. The connecting of these 5 islands that previously were just by ferry or some not at all, being able to connect all of these with a single transportation project that's pretty interesting is combining both tunnels and bridges, artificial islands, and they're using these crazy techniques using not only just the drones, but the 3D data as well in order to update stakeholders, update the clients, and the Norwegian people. And with that, I think we're going to open it up to a few questions.
Great. Thank you so much, Jeremiah. Like you said, we will now open up the session to the audience to ask their questions. In order to submit a question, just as a reminder, please use that Q&A box in the bottom right corner of the screen, or if you're viewing the program in full screen mode, via the toolbar at the top of your screen. Just type in your question and hit the submit button. We already have several coming in, so let's go ahead and get started. The first question that's come in: how accurate are the results, and how can that be measured?
Well, that's a really good question, and it's actually one that we get a lot. When you're talking about photogrammetry and stitching, photos from drones, it's really important to make sure that the data that's being stitched together is as accurate as possible. And one of those ways that you do is importing ground control points, or GCPs. These are survey points or known points that are visible from the air, and you might be familiar with the black and white checkerboard squares that you can put out, or the X's, and you would have a surveyor that would go out and survey that point. But they don't necessarily have to be the checkerboards. You can really use anything that is seen from the air. On a lot of transportation or city projects, I like to use manhole covers, something that's very easy to spot, something that doesn't change over time. And that way, flight after flight after flight, you can see those manhole covers. And the way it works in SiteScan is you take that survey data as a CSV file. So a CSV file that contains the X, Y, and Z of the coordinates. And if it's a black and white tile or painted X mark, SiteScan will actually use machine learning to automatically find and tag those points. And then it's just up to the user to verify that everything was tagged appropriately. But if you're not using some of those commonly used GCP points, then you can click on the GCPs and do the tagging workflow straight from the web browser. So you would click on a ground control point, click on a photo, and assign that photo to that ground control point. Once you've done that, you can expect accuracy, depending on how high you're flying and how high resolution the photos are. You can expect accuracy between 2 to 5 centimeters, or about an inch or 2.
All right, great, thank you. The next question is from Michael. How long does it typically take to plan and authorize a mission using these tools, the site scan tools?
Well, planning a mission is pretty simple. You're just defining the polygon, you're defining the flight type, so an area survey where you're capturing an area, or a perimeter scan where you're flying around an object. That's all pretty simple to do. It just takes a minute or 2. But if you're talking about maybe authorizing a mission, so maybe talking to somebody like the FAA here in the United States to authorize a flight, it really depends on where you're at. If you're next to an airport, if you're kind of in the middle of nowhere. If you're not familiar already with LAANC, L-A-A-N-C, here in the United States, you can get authorization to fly in areas without necessarily having to request formally to the air traffic control facility to fly there. It's an online submittal, and you can actually do that within the SiteScan flight planning app. So within SiteScan, as you're planning your flight, if it sees that you're in an area of controlled airspace, you can actually submit that LAANC application automatically from the iPad. Now, I don't know about much about requesting flights in Norway. Øystein, can I put you on the spot here? Could you describe what it's like to get authorization to fly in Norway?
Yeah, you can ask. It's not my field of expertise, but to get, we are kind of qualified as an, what should I call? Maybe you have to help me here, Anders, but we have our own operation manual, which is specified to our equipment. We have to get approval from the air authority. So we have our own I don't know to call it flight vessel number series. I don't know what to call it, but we are on a list of registered not flight companies, but drone
certification maybe.
Yeah, they're certified as a drone flyer.
Yeah, we have a similar certification here in the United States, a Part 107 certificate in order to fly a drone commercially. So it's very similar.
Yeah, and all the pilots need to do a official kind of program with exam and a test in the end, which you need to pass on a official traffic station.
Yeah.
And then qualified for flying within Skanska.
Great, thanks.
Perfect. The next question is from John. Is SiteScan available for Android devices, or is that planned in the near future?
Yeah, so right now, SiteScan Flight Planning app is just iPad only. We did that for a number of reasons. One is just for simplicity's sake of seeing so many iPads out there in the world, and a lot of our users already having iPads existing. But we do see, especially internationally, the requirement for different operating systems other than iPad. And so we're currently evaluating what it would take to port this over to Android devices. I don't have a timeline on that, but it is something that we are hearing from the industry and something that we're looking at.
Wonderful, thank you. The next question is from Bert. Does the SiteScan Flight app work with the new DJI Matrice 300?
Great question. So the Matrice 300 is DJI's newest piece of hardware. We are currently working with DJI to support that drone. The SDK is it's either not released to the public yet or just about to be released, and it's something that we're working on integrating into the app as well.
Perfect. And as sort of a little follow-up to that, does SiteScan work with all of the other DJI drones?
Yeah, so SiteScan works with most DJI drones, save for some of the older ones. or some of the more consumer versions, so like the Mavic Mini or Mavic Air is not supported by SiteScan, but any of the main DJI drones that we're seeing today, so Mavic, Mavic 2, Inspire 2, Matrice 200, RTK, and they're all supported by SiteScan today.
All right, great, thank you. The next question is from John. Can you bring in a published feature service for reference for flight planning or a shapefile? Yeah,
there are a couple of ways to do this. When you're creating a project within the SiteScan application, you have the option to upload KML files, shape files, or PDF files that can be used in the field to create those flight plans. And you know, when you're pulling the flight plan up on your iPad, you can turn on those overlays and see the overlays as you're planning. Another way to do that is to connect your SiteScan flight planning app to your ArcGIS Online account. And anything that you have in ArcGIS Online, you know, 2D or 3D, if it's imagery or point signs and polygons, you can pull those in and plan your flight plan that way.
All right, wonderful. The next question is from Donovan. How are you checking the airspace prior to flight? And what if you're in a controlled airspace or have to mitigate a TFR?
So the SiteScan flight planning app uses AirMap to verify airspace and TFRs. That's something that you can also turn on in the overlay section. And that's what we use to verify if you're in controlled airspace and whether or not LANC is available for your location. Obviously, that's pretty United States centric. Internationally, AirMap does have you know, polygons for distance from airports and things like that, but you would have to work with your you know, your country's airspace administrator in order to get approved to fly there.
All right, great. The next question is from Bart. You mentioned swapping out the battery during flights. Can you move the home point during missions for longer missions or for long, slender flight plans?
Yes, you can. So, you know, the drones, the takeoff point isn't really a required known point. So we have customers who are planning these longer, slender flight plans where they'll fly and then they'll change the battery and drive up to a different location and take off from there and continue the flight plan that way. The drone just registers its takeoff and landing point just like you know, it would normally if you were hand flying it, and it'll just go to whatever waypoint it left off at before the battery change.
Great, thank you. The next question that has come in is from Rufus. Can you increase or decrease the flight altitude of a mission?
Yes, you can. So when planning the mission, you will see a slider on the left for how high you want the drone flight to be. And then at the bottom, you will see data showing how long the flight will take, what the resolution of the resulting photographs will be, and what you know, how many tiers or how many lines, if it was a vertical mission, that it would do. So just by sliding that little bar, you can kind of see how changing altitude will affect the resolution and number of photos the data has.
All right, great. The next question has come in from Pete. If you remove the SD card, do you need to reinsert the same SD card based on flight plan data, or can you use a fresh one?
I always recommend using the same SD card just to prevent mismatch of data, but that isn't a requirement of the application. It'll just make the photo transfer process just one more step because you have to use 2 SD cards.
All right, great, thank you. Rebecca has asked, does the Civil 3D data export, and then is the data compatible with AutoCAD Civil 3D surface format?
I might be able to answer this one, but maybe I can hand it off to Anders, who knows a little bit more about the Civil 3D stuff. So the question was about
I'm not sure.
pulling the site scan point clouds into Civil 3D.
I mostly worked with the GIS link, so I'm not sure what format you can export from SiteScan. I guess you can export the meshes in DVG format, maybe.
Yeah. From talking to my customers, they're able to take the LAS files directly from SiteScan, and sometimes they have to be converted into RCS files or a recap point cloud file to be pulled in directly, but that's how they're doing that.
So I guess it's compatible. It's possible to take the data into Civil 3D, but you have to do some. It's not a direct connection.
Mm-hmm.
Actually, I think it is. We can process the RCS file on SiteScan and kind of throw it to BIM 360, where you can connect with AutoCAD Civil 3D.
Yeah, but I'm not sure if you get this surface model. You can get the point cloud direct in almost, but I'm not sure about the surface model. Maybe.
Yeah, I think that they might pull in the DEM file and import that as a surface.
Yeah, that's possible. Yeah.
Yeah, that was one of the things that I wanted to mention that I forgot too early on in the presentation, is that there are two connectors. There's one connector that goes into ArcGIS Online, and there's another connector that goes into BIM 360. So if you have a BIM 360 project in an account, you can actually link your SiteScan credentials with your BIM 360 credentials and transfer those files directly to BIM 360 projects as well.
Great, thank you. The next question that's come in is from Terry, and it's, will SiteScan replace Drone 2 Map?
Great question. I get this one a lot. So when we talked about the drone collections earlier on in the presentation, kind of talked about an offline versus online drone workflows, and there are use cases for both. In fact, we have customers that are using both. They're online for standardized cloud processing at scale, but then if they're in an offline environment where they don't necessarily have internet or a slow internet connection, they'll be using Drone 2 Map to process that data locally. So it's really use case dependent, but no, the SiteScan will not be replacing Drone 2 Map. They have two distinct roles within the drone collections.
Right, great, thank you. The next question, we've got a couple questions come in about cybersecurity. So one is, what measures are used to protect data? And the second is a little more specific. Many clients have IT security requirements that prevent transfer of sensitive data, such as imagery or infrastructure. And how does SiteScan or Esri encrypt this data in a live stream event?
Well, I'll be honest with you, I'm not the guy to ask in regards to IT security, but I will say that the data is encrypted at rest and during transport. It's stored in Amazon S3 and in private buckets. And yes, we do have customers that they cannot stream sensitive data to the cloud. That's another use case for Drone 2 Map. So keeping that data offline and not accessible in the cloud is one way to do that. But Esri as a whole takes cloud security very seriously. Obviously, we have customers around the world who their data privacy and data security is the #1 concern. So it's something that we do take very seriously. I just happen to not be the right person to ask when it comes to the data security questions.
No problem, thank you. The next question is from Terry, and does the flight planning modes include circular flights with an oblique view?
Yes, so we have a few different types of flight plans. We have flight plans. Let me actually back up. Let me see if I can go to this slide here. This one. So when you're looking at these different flight plans, we have a few different ones. They have area survey and cross-hatch survey, which you define as a polygon, and you'll either fly one way, or with cross-hatch survey, you'll fly in two area surveys perpendicular to each other. But we also have other vertical flight plans like perimeter scan or vertical scan. Perimeter scan, where you define an object of interest, and the drone will fly around that object at different heights. So you define the object, you define how high that object or how tall that object is, and then it will define those tiers to fly around it. If you can't fly completely around an object, you would use a flight plan like vertical scan. So vertical scan is great for the faces of dams, the sides of a hill, or the side of a bridge, or around two sides of a building that you can't necessarily fly around for legal reasons. And you would define the vertical face. You can also define if that face leans or not, and then how far does it lean, and the flight path will be generated that way.
Great, thank you. Robbie would like to know, are you utilizing PPK or RTK for data capture?
Yeah, so we support PPK and RTK. A lot of that is drone specific. So a lot of that isn't controlled necessarily by site scan, but if you are using a drone that has PPK or RTK corrected data, when you're uploading and processing the data, you can define how accurate the geotags are in those images. So whether you're doing real-time correction or post-processed correction, you're going to get a little accuracy number that you can put into site scan to define what the accuracy is. There are a couple of DJI drones that have RTK, hardware already embedded. So if you do have that and RTK real-time correction of the geotagging of photos is supported by that aircraft, then you can turn that on in the site scan flight planning app.
All right, great, thank you. Barry would like to know, does SiteScan support thermal sensors?
Yes, it does. So the XT and XT2 are two thermal sensors that DJI has for their aircraft. And yes, we support the processing of the thermal data. Obviously, if you're processing thermal data, there are certain things that you want to do in order to ensure that thermal radiometric data is accurate. But once you have those calibrated, you can view and process the thermal data within SiteScan.
Perfect, thank you. We've had multiple attendees asking, what drones does SiteScan support?
Mm-hmm. Yeah, so the list is fairly long, but the majority of the DJI drones that you're seeing today, we support, say, for the smaller Mavics. So M200, 210, 210 RTK, Inspire 2, Phantom 4 Pro, Phantom 4 Advanced. There are the unique H520G, and obviously we're looking at supporting others that are coming down the pipeline, like the M300, which we talked about before, and other non-DJI pieces of hardware.
Great, thank you. Dave asked, what type of cameras do you use, and are they mechanical shutter or electronic rolling shutters?
We support the cameras that is used by the drones we support. So depending on what you're using, so I know the DJI X4S is a mechanical shutter, but the X5S is a rolling shutter. So it really just depends on what camera you have strapped to the drone and what hardware you currently have. SiteScan, the processing application really doesn't care what sensor the data was collected on. As long as it's a JPEG image that has geotags in the EXIF, then it'll process.
Great, thank you. Another concept from multiple attendees asking the same type of question. Do you support multispectral, hyperspectral, or LiDAR?
Great question. So we are currently working on multispectral data and processing that. We have a couple of customers that are testing that functionality. I don't think we have plans for hyperspectral imagery, and I think we're going to see a little bit more of LiDAR support as we see drones with LiDAR equipped. Today, the market for that really isn't that large, but we're starting to get that asked a lot, so it's something we're looking into.
Awesome, thank you. From Nicholas, is the question, how does the data flow between ArcGIS, Autodesk, and SiteScan? Does it require manual exports?
No, so like we said, we have two different connectors. So one is an Esri connector and one is an Autodesk connector. For the ArcGIS Online piece, once you've logged in with both your SiteScan credentials and your ArcGIS Online credentials, it'll pull up and you're able to directly export the data from SiteScan to your ArcGIS Online account. And the files aren't just dropped into your ArcGIS Online account. We actually have middleware servers that will create scene layer packages, tile packages, hosted elevation services, all ready for you. So our customers are able to just directly export to their ArcGIS Online account, and then all the data is hosted and ready to go immediately.
Great, thank you. The next question is from Kyle. With all the visualization and integration that Skanska is doing, are you also finding cost savings with respect to construction sequencing and identification of unknowns?
I guess I would say that with respect to construction, I'm not sure about construction sequencing, but as I understand it, you don't necessarily find cost savings with respect to construction, but the photos, they are more like a guarantee that you have the documentation you need in the project, and that you kind of tell the rest of the project team with more quality what the progress is in the project. It's with so many 3D models that we use in Skanska, it's difficult for team members to really understand the progress of the construction without being able to see the models together with, for example, measurements from stakeout equipment or from the drones. So it's more about documentation than anything else, I would say. Øystein?
Yeah, you're right about that. It's also to kind of identify the progress in the constructions. And also, as I mentioned, the drone data collects all kinds of data. So sometimes when we lack measurements from some kind of pipeline or whatever, we have it somewhere in the data. We have it. If you're not unlucky with the dates we have flown, we usually can find some data on pretty much everything during the lifespan of the project.
Wonderful, thank you. We are running short on time, so to be respectful of everybody's time, this will be our last question, and it's from Dell. Can the SiteScan drone app capture the accurate latitude, longitude of locations?
Yes, so this kind of relates to the ground control point question that we had earlier. So, you know, the data that's collected straight from the drone is going to be accurate within, 3 to 6 feet, 1 to 2 meters. But in order to get more accurate data, you really need to apply survey control or ground control to the data so that the resulting data points from the ortho and the point cloud and the digital elevation model are as accurate as possible.
Wonderful, thank you. And I'm sorry we're short on time and we don't have time to answer the remaining questions that have come in, but we'll be sure to share those with our speakers today. So we have reached the end of our session. On behalf of AUVSI, I'd like to thank our speakers for their excellent presentation and discussions this afternoon. And we'd like to once again thank Esri, our sponsor, for your time and support of today's webinar. Attendees, you will all receive a link to access the webinar recording along with a copy of the presentation within the next few days. So in addition to this webinar, AUVSI is working to bring more and more virtual content in the coming weeks. So here's a look at our next 2 scheduled webinars, and please be sure to visit our website, auvsi.org, for a complete list of upcoming programs. If you have any questions or comments, please reach out to me at education@auvsi.org. Lastly, today's program is copyrighted with all rights reserved. So thank you all and have a great rest of your day.